So in the current runtime, by default, when you run a GameMaker game, GameMaker will take all the code you've written, and it will compile your code into not native machine code, but a proprietary bytecode format of Yoyo Game's own invention. And that bytecode will run inside the GameMaker Virtual Machine. And the GameMaker Virtual Machine will execute each of those instructions in turn, and it will, in the end, produce on the screen your game. And of course, somewhat famously or infamously, the trade-off for this is that it's a little on the slow side. Performance sometimes leaves a bit to be desired. Although for your average GameMaker game, this isn't that much of an issue, since we are typically not doing things such as running NASA supercomputer simulations or anything of that sort. And then, of course, GameMaker also has the Yoyo compiler. The Yoyo compiler is a bit beyond the scope of this video, although if you're interested in that, I did make a video on it a few years ago, which you can go and have a look at after this. And there comes a time in every developer's life in which they may start to wonder what exactly happens inside the GameMaker Virtual Machine. And there's the result of that math calculation. Cool, GameMaker can do basic math. Maybe saying every developer is a bit of an exaggeration, but if you've ever wondered exactly what happens when you hit the F5 key and GameMaker builds and runs your game, we can actually look into that a little bit. So today, I'm going to essentially run the GameMaker asset compiler myself. We're basically going to build the game from the command line, and I'm going to do that with a few additional parameters, and those additional parameters are going to actually print out each and every GameMaker Virtual Machine bytecode instruction, and that's going to allow us to have a look inside what's happening. And I'm not going to make a full-blown tutorial on like how to read GameMaker bytecode or anything like that, but this is something that can be useful all the same. So what I'm going to have to do is I'm going to have to open up a command prompt. Windows. Alright, on Windows 10 and 11, you should be able to open a command prompt just by typing CMD into the start menu, but apparently it doesn't want to do that today, so I guess we could do this the old-fashioned way. Open up the run dialog. That's the Windows key and R. We'll open up the run dialog, type CMD into that. You can open up a command prompt. So what we're going to want to do is we're going to want to go into the output, into the compile output of GameMaker. You're going to want to find the line that says run asset compiler, and you're going to want to take the line beneath that. You're going to want to select it all, copy it, Control-C to copy if you want. You're going to want to go into your command prompt, use the .net command /program, paste in that entire line. Right-click to paste is sufficient in the old-fashioned Windows command prompt. You don't have to Control-V or anything like that. And we're going to throw an extra parameter onto the end of that. So I'm going to hit /CV after this whole big old line has been pasted. And that is going to basically enable verbose compiler output. And if I hit enter, that's going to take a moment to run. You may see some things that look familiar. You may see some things that do not look familiar. For example, if you scroll all the way up, you'll see a lot of the text that appears in the console when you run your game in GameMaker. And underneath that, you'll see a lot of abstract syntax tree stuff. That can also be fun if you're a compiler nerd. And the part that I'm interested in is going to be down near the bottom. We are going to have, in essence, a whole bunch of GameMaker assembly instructions popping out in the console. And this is the GameMaker bytecode. And I know that I said that I wasn't going to make a tutorial on how this works, but if you look through it, you can see some familiar values. So you push the value 25 onto the call stack, you pop the value on the call stack into variable A, you push the value 10 onto the call stack, pop the value onto variable B, and then so on and so forth. You can see we are later calling some show debug message functions. So this is what GameMaker actually sees when it runs your game. Specifically, what it sees is like these values here on the left side. That's very interesting. And as I said up here, we also have the actual abstract syntax tree, which is the intermediate steps between turning your source code from like this text into this bytecode. It's not very complicated in this example, but you can imagine that if you have an actually fairly large game with a lot of if statements and loops and variables and that kind of thing, then it can be quite a bit more complicated. So in my mind, there are two main uses for looking at this. One is just because I think it's inherently interesting, and I do like knowing like how the sausage is made and like what the engine is actually doing. And if you're interested in learning a thing or two about how computers work inside, then this may be of mild interest to you. And the other thing that you can glean from this is actually when it comes to optimization, if you're finding that writing your code in one style is faster or slower than writing your code in another style, and if you're wondering why, then not always, but sometimes if you look at the actual bytecode, you can get a hint as to why that may be. And I tell people all the time not to worry about micro-optimizations, and looking at the GameMaker bytecode is basically as micro-optimization-y as it gets. But I am soon going to make a video on optimizing a 3D collision system in GameMaker, and long story short, that tends to be the sort of thing that you need to pull out all the stops for. And if you're trying to optimize a system of that nature, then getting this deep into the computer science can actually sometimes be a help. So let me explain the lay of things before I get really into actually comparing bytecode operations to each other. So for the most part, all of these operations are about as expensive as each other. Obviously, there are some like function calls that are more expensive than other function calls. If you were to use like an MP grid pathfinding function on a grid that's really big, that's obviously going to be a little bit more expensive inherently than just like a boring little show debug message, even though both of those things are just going to include a single call function, virtual machine instruction. But when it comes to basic math, addition, subtraction, multiplication, division, yes, division, basic math functions, absolute values, square roots, that kind of thing, all of those operations are about as expensive as each other. And therefore, if you want to really micro-optimize your code, what you really want to do is have GameMaker run as few of these as possible, rather than doing any clever like floating point hacks, avoiding division, avoiding trigonometry, things that people on Reddit love to scream about and in actuality are really of no consequence. So if you want, and I'm not actually going to print out the actual result here because we don't care about the result as much as we care about being able to read the virtual machine output. If we were to have one line of code which evaluates a plus b and another line of code which evaluates a divided by b, if I were to run this again and look at the bytecode, these are going to be the lines of relevance. Push A onto the stack, push B onto the stack, do an addition operation and pop the value into the results variable. And down here, push A onto the stack, push B onto the stack, do a division operation and pop the result into the results variable. Both of those are for GameMaker Virtual Machine instructions. And again, each of these instructions is about as expensive as each other. There is a decent amount of overhead involved in each of these instructions, checking types, constructing and destructing the internal data structures which actually represent each of these values. Please feel free to divide by 2 instead of multiplying by 0.5 wherever and whenever you want. Also, by the way, this also shows us a bit about something that GameMaker doesn't do, which is that some more robust compiler optimizers will notice that this value is never actually used, and therefore it will just eliminate it from the final compiled code. GameMaker will not do that. For better or for worse, be nice if it did. I don't know if that's something that will be featured in the new runtime LLVM compiler toolchain, but that's where we are right now. So let's move on to something a little bit more interesting. Let me define a few more variables. I'll say C equals Oh, I need some numbers. Let's talk about dot products. So GameMaker has a built-in dot product function. It actually has a few of them. Dot product 3D, 3D normalized, and dot product normalized. I'm going to go with dot product 3D. And you can feed in values into this dot product function, 6 of them. So I can just say A, B, C, D, E, F. And I can label that so that we know which section of bytecode we're looking at. And then you might think about doing that yourself. So the dot product equation is calculated by saying A times, in my case, D plus B times E plus C times F. It'll give us the same answer, but if we're curious which one produces more efficient bytecode, which one uses fewer virtual machine instructions, we can run the ASCII compiler again. There's a bit more of it this time. So once the previous thing that happens before this is popping the variable f off the stack, so that's where the previous line ends. So this line is where the built-in dot product starts. That's going to go down to here, where the value is popped off the stack and stored in the results variable. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8 virtual machine instructions. And down here, doing it manually ourselves, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 virtual machine instructions. So doing the 3D dot product manually yourself is 50% more GameMaker Virtual Machine instructions than using the built-in dot product 3D function. So that is an example of some genuinely useful information that you might get out of looking at the GameMaker bytecode. So there's all kinds of other things you might consider doing with this. We have, for example, just saying A times A versus using the square function. Things of that nature, different bits of math you might be interested in looking at. There's everybody's favorite GameMaker feature to argue about, which is repeat loops versus for loops versus while loops. You can do that test on yourself to see what that bytecode looks like. I did mention optimizations that GameMaker doesn't do in discarding values that are just never used from the final game. And there are actually a few optimizations that GameMaker does do, which you may be interested in. So if I go back to saying A plus B, you remember what this looked like, right? And I'm just going to get rid of everything after that because I don't need anything else. You push A onto the stack, you push B onto the stack, you do an add operation, and then you pop the result into the variable. Once again, this is what it looks like. But what if you were to, instead of saying A plus B, you were instead of to substitute the literal value of 10 plus the literal value of 25? What would this look like? You might expect to see basically the same thing, but instead of pushing the value of A and B onto the stack, you would push the value of the literal numbers 25 and 10. But if we were to run this, we would see that this is actually not what happens. And let me actually comment those out so that I don't have to hunt through the output to see what I'm looking for. We can see that what actually happens is that we simply push a single value, 35, onto the stack, and then just stick that in the variable. So if you have an expression like this, which can be evaluated at compile time, so if GameMaker, at the time of you hitting F5 and building the game, already can figure out what this value is going to be, it will do that computation ahead of time. And instead of storing two values, 10 and 25, it will simply add those together ahead of time and cut the chase, and all it will see here is the actual value 35. So that is a compile time optimization. That is fairly nice. It's probably not something that you will come across too often, but in certain cases, it can make your code more readable. So another optimization that GameMaker will do for you, which you might notice if you mess around in the bytecode, so for one, Feather understands that this code will never run, which is quite clever of it because it's if false, that's silly. But if you were to run this, and I should maybe just put a dummy variable up there so that there actually is bytecode to look at to begin with. If you were to run this, you will see that this code is also completely eliminated from the compiled game. And this code on its own is kind of useless, but if you have something like a macro to work with different configs, which you might use to turn on or off different features in your game, if you were to use the macro, which has a literal value of either true or false, inside an if statement, if the value is false, then the entire block of code will be removed, and GameMaker will never include that in your finished game. And if it's true, you'll basically get if true, and the code will just be included in the output without actually like including a control flow if statement in the bytecode. So if you've ever used macros to turn features on or off in different versions of your game like that, then you don't even have to worry about the code being included in versions of the game in which it will never run, because GameMaker is smart enough to just remove that to begin with. So I'm going to end this here. I'm sure there are other optimizations that GameMaker does, which you can find out about by looking at them in the bytecode. I'm sure there are other interesting things that you can find with regards to performance between math operations and different ways of doing things. So a few notes before I go. One, this is almost certainly going to be not how it works when the new runtime comes out. That's probably, I want to say, about a year off. I want to say the last ETA I heard for when new runtime officially comes out is like the second half of 2024. But until then, you can do this, and you can possibly find some interesting things. And two, I would not recommend looking at this alone when it comes to judging performance, because as I said, certain functions are more expensive than others. Some are obvious, such as like MP grid functions, collision functions. And some of them may be a little bit less obvious as to why they are a little on the slow side, such as the string character at function and some other string functions. And before you jump to any conclusions about the performance merits of different kinds of code, I would definitely recommend actually testing it in the real world. Whip out the benchmark tool. If you've got it running in your game, look at the profiler and see for sure if the code you're running is actually fast or slow, and then use this to try and find out why that is the case, rather than just looking at the bytecode and saying that this is 4 instructions versus 6, therefore it must be faster. And lastly, pretty much any optimization that you find by looking at the GameMaker bytecode will qualify as a micro-optimization. In pretty much any real-world scenario, someone sneezing in another room will have more of an impact on your game's performance than a single dot product operation. These sorts of optimizations really only become relevant if you're trying to do tens or even hundreds of thousands of these operations per frame. Alright, so that's it for me. My name is Michael. I like wizards and dragons and making games. If you like looking at the weird, obscure, and otherwise nerdy things about GameMaker, I like to make a lot of videos of this sort, particularly pertaining to 3D, so if any of this appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. Soon, I will be hopefully finishing off the aforementioned 3D collision series in GameMaker. Very exciting. And then immediately following that, I will be using that to make a 3D wizard game. Very fun. I hope you all find this useful, and I will see you all later. Special thanks to Zenjamin, VitroV, Squarecrow, Syndra Larson, Manta Ray, GameMaker, Edward Holt, DJ Gibbles, and Army Armbruster for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.